Hello, this is Udo from Sanuk Bistro and Cafe. You maybe know that I not only love coffee, but I also like bicycling quite a bit. And we do not only go on long trips, as we did in summer 2019, our trip around France, but we also use the bicycle on our daily jobs, on the daily things that we have to do if we go shopping or we want to go city center or whatever we want to do. We also use the bicycle, and especially in winter time when the days are very short, it's quite easy that it's getting dark and you need a front light on your bicycle. I had some kit eye lights for the last couple of years, but they kind of tend to break somewhere here in housing. I had 3 of these guys already. So this time I decided to buy another one, to try another headlight, and I decided for the Busch Müller IXON IQ Premium. It's specified with a light intensity of 80 lumen in high beam mode and 15 lumen in economy mode. The batteries are specified to last for 5 hours in high power mode and 20 hours in economy mode. There's a total of 4 batteries included. I had some 2600 milliampere hour rechargeable batteries left over, which I put in here. When I unpacked the device, I was actually a little bit frustrated when I saw that the plug for charging the batteries is not a USB plug, but it's just a standard low voltage power supply used in many other electronic components. I tried to charge with USB power supply, but actually nothing happened. So what I did, I checked in internet and I found specifications for the power supply from Busch Müller that they designed especially for the IXON IQ Premium, and that power supply has a no load output voltage of about 8 volt and it's limiting the current for about 0.5 ampere. So that means that most of the circuitry to control the batteries is included in the power supply. I didn't buy the power supply because I wanted to use this device with USB chargers or USB power banks, because when I'm traveling I may or may not have accessibility to a mains power supply. So finally I was a little bit frustrated when I saw that this device cannot be used with a standard power supply USB. The idea was to use a DC-DC converter to convert the voltage from USB 5 volt to this device up to 8 volt and to build some electronics around it to make sure that we can also control the maximum current to limit that for 0.5 ampere. I bought this DC-DC converter. The specification or the type is in the link below, in the description below, and there was a small potentiometer up here where you could adjust the output voltage. I desoldered the putty and I'm using the center pin as a control pin. It's directly connected to the feedback pin of the integrated circuit. So depending on the feedback pin or depending on the control pin, we can now adjust the pulse width of that device, or in other words, the output power. If the pulse width gets wider or we have longer on pulses, then the output power is higher, and if the pulses get lower, then the output power will also be lower. I will explain a little bit more about that circuit that I built around it in just a second. As I said, we want to go into the device in more details. This is the circuit diagram. You will see USB input, our DC-DC converter with the control input. As I said, the control input internally was before controlled by a potentiometer to adjust the output voltage. We took off the potentiometer and now we feed that input out to our own circuitry. The output is directly connected to the output terminals. The negative ground terminal includes a small shunt resistor of 0.5 ohm, and that shunt resistor will be used to measure the maximum current. We have a dual operational amplifier, LM358. That's a pretty standard type dual operational amplifier, which should be available more or less everywhere. The USB connector is also connected to an LED, which just displays that USB is plugged in. One operational amplifier is actually connected to the output voltage and with potentiometer, so we can adjust the maximum output voltage in a range from like 6 to 9 volt. The two diodes at the outputs will make sure that only one of those two operational amplifiers becomes active to actually start limiting the output power. So one is the maximum voltage, which is controlled here. If the maximum voltage exceeds, then that output goes up and the pulse width will be reduced. The output power will be reduced. The other part is the maximum current. So here we have a shunt or current sensor. We amplify that by a factor of 5 to 10 with that operational amplifier. So that finally we can adjust the maximum current from 0.25 to 0.5 ampere, and we can control the maximum current. There we also have another LED which will light whenever the current control is active. So whenever this is limiting the pulse width, then there will be a voltage of about 1.9 volt here, and this LED will be turned on. Okay, now that you've seen the circuit diagram and you understand the way it works, I will give you a demonstration, but before that I will just screw it in and then we can connect it to a power supply and see what's happening. I have a standard Samsung power bank that I want to use to source the device now. And as you can see, the power LED turns on once I connected it to the power. So we now connect the output with our IXON light. We see that the charging control turns on, and we can also see that the green LED here turns on, which means that yes, he's charging. The batteries are actually almost full, so I'm very sure we can wait for this one to switch off, so we can also see how that finally would look like. Okay, you just saw that it was flashing a little bit. Now he switched off this LED. That means he's now controlling maximum voltage or not controlling maximum current anymore. So there's still some current flowing, but actually that should not be too much anymore, and we can assume that it means that the battery is more or less charged. One thing I should mention here, this LED is still on, and the manual says that when you take it out while you're still charging, then this can happen. But anyway, if we now turn on the LED in high power mode, we will see that this is flashing and it's only a very short time off and long time on. That means that the battery is almost fully charged. I want to thank you very much for watching the video. I hope you liked it, and I hope to see you again soon.